Alright, it's your boy the Canologist. Let's look at this problem here. This Leetcode is guess number higher or lower. We're playing the guess game. Pick a number from 1 to n. You have to guess which number I picked. So someone else picks a number. Okay, cool. Every time you guess wrong, I will tell you whether the number I picked is higher or lower. This already sounds like some sort of binary search. You can call a predefined API int guess, which guesses 3 possible results. -1, 1, or thing. Return the number that I picked. Zero calorie. Okay. The number is between 1 to n. And picks between 1 and thing. Okay. Return the number that he picked. So you could always just always guess 1 and just count up till n, and you get O of n time. That's the way I'm like thinking of doing it. So pick So if the pick, so it's gonna guess for you, right? So it's gonna return either -1 if it's greater than, 1 if it's less than, or 0 if it's equal to. So if pick equals to greater than, you just go while loop. I'm gonna call this my pick, or yeah, my pick. My guess equals 1. And I'm subbing my guess, right? So then now I can just increment it, and this is my base pick. It's never gonna be less than 1, because of the constraint. So if pick equals -1, so it's definitely going to be greater than. Else return 1. I don't even need to put an else. Just return 1. Because it's not equal to -1. If pick's not equal to -1, then it's automatically thing, because I made my guess 1. So you can eliminate the whole less than case. It'll never be less than if you start with your guess. And then he has to tell you higher or lower based on this API call. So it's always going to say higher, 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 higher. So I just run my while loop. Go while pick. If pick equals -1, that means it's higher. Otherwise, return 1. So if he picks 1, I get 1. Otherwise, if it's higher, while pick is not equal to 0. So pick is the actual returned value. So I'm just going to put while guess. So pick is the first return value. This is my first return value. So then from this onwards, I'm going to do guess. And then my guess equals 0. So if it's not equal to 0, which is the exact number, keep going. So then it'll be my guess plus equals 1. And it's going to keep going until it hits that, and then return there. So the pick go into a while if it's not 0. If it's -1, it's going to go my guess plus equals 1. Boom. That's plus equals 1, plus equals 1, plus equals 1, plus equals 1, until it hits till it equals 0. That means the pick is the number. Then you return the number. You can't have less than 0 or less than 1. So I start my guess at 1 and just increment. I don't have to do a negative case. N equals 10, pick 6. Output 1, expected 6, n equals 10. I pick a number from 1 to 10. You have to guess which number I picked. Okay. It shouldn't matter what n is. Okay, let's get rid of this. For example, if I go here, it's going to be 1. Here, it's going to be 1. So it looks like it's returning 1 in all cases. So why? Guess my guess. Okay, maybe I'm misunderstanding the words. The wording of this is kind of messed up. So let's just see what I'm doing wrong. Maybe the solution. This is one of those verbiage fucking weird questions where it's not explained properly. This is the way I'm seeing it. Okay, I could just call guess on a number that I pick. So I'm going to choose 1, just increment until I find it, then return it. Otherwise, that means they picked 1. Yeah, if my guess is negative, it means greater. Oh, okay, wait. I guess why. This is why. Before I go to ChatGPT, let's try this out. Try this. I'm just curious. Will that work? Yeah. I'm a genius, dude. I'm actually a genius. You see what happened here? So it wasn't working before because I said if my guess is equal to -1. But my guess was already labeled at 1. So if he picks 1, it can't be both cases. It's always going to skip that while loop. Right? In this case, I'm actually using the API, right? So I'm using the API and I'm making my guess 1. So right off the bat, I'm just checking from 1. And if it's not 0, go upwards. So I'm basically saying if it's equal to 1, return my guess, which is 1, I'm done. Right? If it's not equal to 1, keep incrementing it till you find it. And then you don't have to do this case here. Let's try submitting it. It's O(n) time, so might not be the fastest method. Time limit exceeded. Okay, because they did like freaking like exponential numbers here, but I guess they're trying to do a triage of items for higher or lower. I'm pretty sure you could solve this with binary search. You take whatever the value of n is, and then you just add it. So now that we've shown you, okay, so I've shown you my logic. This works in O of n time. But now we have to modify this to make it work for binary search. Okay, so because it's taking too long for the compiler, it's on time limit exceeded. So we have to create a method of solving that doesn't exceed the time limit. So we have to go mid and now it's like log of n time. Cuts in half exponentially. So this is n is the range, and you could pick anything within that range. So I just start at the midpoint, floor it. Then I want to go binary search is I get a midpoint. Oh yeah, I get a left. I get a right. Right equals n inclusive less than to equal to n. So this tells you the constraint for it. So 1 and then n for the loop. So it's going to be, then I define left and right. Mid equals left plus right, floor 2. While left is not greater than right because it's binary search. We're guaranteed to have a pick, so it's going to be in here. So if I could extrapolate this and just bring the midpoint in here because I have to do this every loop anyways. Mid, and then I'm just like intuitively creating binary search, just using logic. So if, now we have to check these 3 guesses. If guess, so this is the pre-built API, is greater than, less than, or equal to. So if it's greater than, so if it's guess equals mid, all right. If guess mid equals -1, this means it's greater, then I want to go the midpoint, it's greater, so I want to move the left midpoint to left plus 1. Because the midpoint is between left and right, and I'm picking the midpoint. I'm taking a guess here. If it's greater than, I have to move my baseline to at least 1 greater than the midpoint, because it's already greater than the midpoint. Then I look at this, and I look at this, and then we keep shrinking it. So left equals thing. right? And then it'll loop again and then take the new midpoint until we hit the guess that we have. If elif guess mid equals 1, right? It's lower than, it's just lower than the mid. So the right is going to be mid minus 1, else the else case is if it's equal to. But I'm going to make it elif, just explicitly define that it's 0. Or I could just put else here. And then it's going to be else return mid. The pick does exist. So if it doesn't exist, like I would have created an extra return where it's -1. But this is like a binary search type of thing. So I create a midpoint that refreshes every loop cycle, right? And then I keep iterating through that loop cycle and then halving my thing as I go. So my midpoint's going to be half every time. So if it's greater than, this is the whole, now it's going to be half. Now it looks at this. If it's greater than, that's going to be half. Or if it's this, if it's less than, that's going to be half. Right? So that's the way you got to look at it when you do binary. You're always cutting the total amount of input in half every iteration in a binary search. That's why you get O of log of n time. It's the inverse of exponential. So exponential takes exponentially long, right? So every iteration takes a huge amount more than the last iteration. In this version of binary search, every iteration takes a huge amount less than the because there's half less inputs every time. So let us try and run it. Let's see what's going on. Okay, null. Let's put less than or equal to right. There we get another case that solves it. So 1, 2, 1, and 6 is null. Okay, so why would that be null? Okay, so if I have 10, 1 and 10 is 11 divided by 2 is 5.5. Floored is 5. So they're going to go 6 to 10. It's equal to, so these are my constraints, 1 and n, right? So then mid equals left is 1, right? 5.5, guess mid, guess thing is right, return mid. How could you ever get a null? Checking on the whiteboard real quick. What time am I at? I'm at 25 minutes. Let's do a quick whiteboard check. There's nothing wrong with that. Okay, so let's say this is 1, this is 10. Right, I want to get the middle, so 1 plus 10 is 11, divided by 2 is 5.5, so 5. Because it's floored. So, let's say the pick is 6, right? The first loop, this is going to go 10. Left is less than right, obviously. And then guess mid, it's going to be either my guess is going to be mid every iteration. So it's going to guess mid, so it's going to be greater than, right? So I guess mid, which is 5, it's going to be greater than, so it's going to equal -1. So guess mid, else, so it's going to go here. I'm going to get -1. So it's going to left mid plus 1. So now I'm going to be at 6 to 10. 6 plus 10 equals 16 divided by 2 equals 8. 8. This pick is 6, right? So the new mid here is 8. So if his pick is 6, right, and we're at 6, then we go 8. Is less than. So it would be right is mid -1. So right is mid -1. So this guess 8 is less than. So we have to go right is mid -1. 8 minus 1 is 7. Okay. And it goes again. Mid. 6 plus 7 equals 13 divided by 2. 6.5. Because it's floored, it's going to be 6. So if 6 goes while left and right is equal, or left equals right, 6 should not return null. This should be the output. So let's explicitly define it here. So if guess mid equals 0, return mid. 6. That should be it. That should be the answer. I should get 6 by the way I traced it out. So maybe because I didn't explicitly define it, let's try it. Why am I getting null? Why am I getting null? Left plus right. Divided by 2. Left. If it's greater than, if the number is higher than, that means I have to move my left. Right. If it's less than, I have to move my right. If it's equal to, I use it. Guess mid equals 0, return mid. So where is the flaw in my logic? I don't see it. Am I missing something? This is where I could use ChatGPT. We're at 25 minutes now. As you can see though, my logic makes sense. So now it's just maybe some syntactical thing that's not correct. That's what I need to figure out. That's interesting. Okay, so here, my code. Fix my solution It is binary search. It's mostly correct. There's a small improvement that can be made to optimize. So calling gets mid multiple times. You can store the result once, use it for comparison. So left plus right plus left. Right minus left divided by 2. Mid. Avoids potential overflow issues. Okay, so it's the multiple calls, the API calls. Otherwise, it's doing everything correctly. So it's the exact same logic. They're just extrapolating the guess mid, and that's what's throwing it off. Okay, so let's guess mid here. That's some good information, right? It's not like my logic's wrong. So it's saying res, and then now I don't have to explicitly define. I could just return mid as is. So I could return res, or I could return mid if it's not these two. So let's run it. Is that the reason? Okay, so it's clearly something more than that. So guess mid, res, -1, mid -1, right is mid -1, -1. Wait, what? Res equals -1, right mid -1. What? If your guess is higher than the number I picked, num is greater than pick. If your guess is higher than the number I picked. If your guess is higher than the number I picked. What the fuck am I doing wrong? So let's say he picks 6. I pick. Let's say he picks 6. My mid returns 8. Right? If it's higher, because he has it swapped from the way I did it. When guess equals, it means guess is higher, so the correct interval to search will be in the lower half. Oh, okay, so it's a reverse logic. So -1 equals mid is right. Right is mid -1. Left is mid +1. That should fix it. Okay, it's just the way I read the question. Boom. Okay, so that makes sense. But if like that's the case, that was the main reason. It wasn't the multiple API calls, but this does just reduce it, make it simpler. But as you can see, it's just some syntactical things. The way I read the question. So I said if your guess is higher than the number I picked, right? If your guess is higher than the number I picked, so if it's 6 and I pick 8, right? It says I have to bring the right value down to 7. Yeah. So it's mid -1. If the right number is higher than the number I picked, okay, so that makes sense. 7. So that means I explained my logic correctly here. I just coded it out the opposite way. So that was the fix here. All right, but you saw the logic; it makes sense, right? So the logic here makes sense, and I got to the actual solution. So I understand what I'm doing, right? It's just that I coded it out wrong here, and then ChatGPT corrected it. So it's just like a quick syntactical fix. Done. Right? Let's try submitting it. This is going to be log of n time because it cuts in half. Boom beats 15.42%. Bob's your uncle, right? If you like this video, please give it a thumbs up, subscribe, and comment below. Knologist out.